Good morning, everyone. I'm sorry I can't be there today. We are looking at Do Now Day 2 from Chapter 6. We're going to do the first one together. Do Now Day 2 from Chapter 6, and then we're going to go on to the lesson for Chapter 6, Day 2 or 3. So first, let's look at Do Now Day 2. So look in your Do Now file to Day 2. And this is the question. It's talking about the probability of customers waiting more than 8 minutes to have their calls answered by a call center. And then if you look down below, it says, what is the probability that at most 2, at most, sorry, I don't have a stylus here at home. At most 2 out of 10 will have to wait more than 10 minutes. So basically, you guys know we talked about at most yesterday. At most is less than or equal to. So you're going to do x less than or equal to 2. So we're going to let x be the random variable on the x-axis, which in this case is the number of callers. And you can have 0 through 7 callers. And then the y-axis is the p of x, which is the probability of the x variable. So remember, this is called a probability distribution histogram. And you see on the x-axis is the x values, and then the y-axis is the p of x values. Okay, so we're interested in the at most 2. So I'm hoping you said to yourself that that's going to be 2 or less. So that's going to be the probability that x equals 2 or x equals 1 or x equals 0. Okay, so the notation is important, especially in this chapter. So we need to make sure that we understand that the P, I'm going to fix this, means probability. And what's up with this thing? Let's stretch it out. Sorry. Not stretching. Anyway, the P means the probability, and we want 2 or less, okay? So we want 2 or 1 or 0. So we're going to add up the 2 or the 1 or the 0. Boom, boom, boom. Add them up. Again, notation. You're going to write P of x equals 2, or P of x equals 1, or P of x equals 0. Okay, and then you're going to add them up. 0.284 plus 0.345 plus 0.181. Okay, and if you add those up, you're going to get choice E, 0.810. Okay, so at most means less than or equal to. At most means less than or equal to. All right. Now, I do want to talk about, I don't know if I got up to it, depends on the class that I was in yesterday, about how to find the median when you're dealing with this. So the median we talked about is the 50th percentile. The median's the halfway point, or the 50th percentile, okay? So when you're talking about percents, this means that 50% of the data lies to the left of it, and 50% of the data lies to the right of it. So when we're doing the median formula, you guys know we add up all the frequencies on the top of the bars, and we keep adding until we reach or surpass the data point that is the median, which we did yesterday. Well, if we're talking about probabilities, we really just have to keep adding until we reach or surpass the probability of 0.5. So basically, if you added these numbers on the top of the bars, like we did, 0.181 plus 0.345, you keep adding until you hit 0.5, okay? So if I add the first 2 bars, probabilities 0.181 plus 0.345, have I reached 0.5? And the answer is yes. So as soon as you hit 0.5 or surpass it, you stop at that bar, and that's where the median is located. So thus, the median, or the center, if we're talking about center in terms of median, will be in this bar, which means that the median will be one caller. If you look on the bottom of the bar, that's one. So the median is one caller. Okay. All right, so that's that. It's the center. And maybe you weren't thinking that the median was at one because visually it doesn't look like one is in the middle. It's not, right? But actually you just have to look for where it accumulates until it reaches the 0.5 mark for probability. All right, so now we're going to skip number 2 for now, and we're going to go over to our classwork. So this classwork is called, in your notebook, I think it's called Day 2, Mean and Expected Value and Standard Deviation of a Discrete Random Variable, or Day 3, I'm not sure. Check out your classwork notes. Let's see. It looks like it's called Day 2, Mean and Standard Deviation, okay? All right, so we just talked about one measure of center. Remember yesterday, we talked about how when we're describing data, we have to address the shape, outliers, center, and spread stocks, right? So we already talked about the shape yesterday, and we started talking about the center just now with the median, or we could talk about the mean. The median we just addressed, that's the 50th percentile. But we are also now going to talk about the mean. Remember, if it's symmetric, the mean will equal the median, and then our work will be done. But the mean, unfortunately, is usually not. It's usually not symmetric. So we're going to look for the mean next, okay? All right, so the first thing is another name for the mean, a synonym, is called expected value. So it kind of makes sense because if you look at this question in context about Pete's Jeep tours, remember yesterday we did it, he was collecting money for the cost of the Jeep tour per person. And on the trip, they let CV the total amount of money that he collected per trip, depending on how many people were in the Jeep. So if we wanted to say how much money can we expect Pete to collect, well, that word expect kind of denotes the average. Like on average, how much money is Pete going to collect, okay? So you guys know in the past, when you found the mean by hand, the average, you would add everything up and you would divide by the total. And that makes sense if everything is weighed the same amount. So let's say you had 5 people, X1, X2, X3, X4, and X5, like 5 tests, for example, in your working period, and we divided it by 5, you take the total points and divide by 5, and that would be your average test grade, right? And remember, we call average the X bar in the past. That's the sample mean. Well, in this scenario, if you look, the probabilities are not all weighing the same, okay? Some are 0.25, some are 0.5, etc. So basically, we have to account for the fact that they're not all like weighing the same amount, okay? So we're going to find the average, but we're going to do things a little bit different. We're still going to add them all up and divide, but we have to account for the fact that they weigh for different amounts, okay? So what you have to do is you have to multiply each x, these are the x's or the c's in this case, times the probabilities, which is called the p of x. So multiply this by this, this by this, this by this, this by this, and this by this, multiply, and then you add them all up. Remember, there is that concept of adding them all up and then dividing by the total. Well, the dividing by the total is kind of accounted for in the fact that we're multiplying each by how much it weighs, which is the probability or the ratio of each outcome, okay? So basically, again, what's going to happen is you're going to do 300 times 0.15 plus 450 times 0.25 plus 750 times 0.20 plus 900 times 0.05, okay? I'm sorry for my handwriting. But basically, on the AP, you don't have to write this fully out. You're allowed to just write the first term and then a plus sign and the dot, 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 and the last term, which I'm going to show you a little later on. So basically, this is what's happening behind the scenes, and that is called the mean or the expected value. So as you can see, the notation that they're using here is mu of C. And they're using mu because it's the population mean, meaning that it's the mean of the entire distribution. So it's not a sample, it's everything related to Pete and his Jeep tours. But another name for it is the expected value. So we're going to also call it E, capital E of C. Now this formula is going to be located on your formula sheet. So in your formula sheet, you guys remember we were in Roman numeral 2, probability distributions, and we did these two formulas already in the past weeks. So basically, you're just going to look right under here where it says this discrete random variable x. That's where we're at. And right now, we're focused on the mean. So you see the formula. It's mu of x. Another name for mu is mean. And another name for that is expected value. So E of x or mu of x. And basically what this is saying is you take the product of all the x's and their respective probabilities, and then this symbol, which is called sigma, is a summation, means you add them all up. So multiply, 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 add them all up. And that's actually what we just did. So if I back up a few slides here, now this is going to make a little more sense. This is the formula here. It has the probability distribution table. It has the x's and the P of x's. Sorry, x's and P of x's. So to get the expected value or the mean, expected value E of x or the mean, the population mean, you're going to multiply, multiply, multiply every x by its respective probability, and then you're going to add them all up. Add, add. So that's what this is showing here. And then remember, this symbol is called summation or sigma. S-U-M-M-A-T-I-O-N, summation or sigma. Okay, and that's a Greek letter, and that just means add them all up. All right, so let's do another example here. Oh, and I just want to show you one more thing. I want to show you that we can check this as well in the calculator. So, all right, let's actually do it. Let's go to our calculator first. Okay, so we're going to do 300 times 0.5 plus 450 times 0.25 plus 600 times 0.35 plus 750 times 0.20 plus, last one, 900 times 0.05. And hopefully I didn't make any typos, because if I did, I'm screwed. So I got 562.5, okay? So let me write that down. And then it's going to ask me to interpret it. And because it's money, I'm going to add a 0 here and make it $562.5. And remember, this is Pete's Jeep Tours, and they're going to ask me to interpret it in words. So he is charging $150 per person. And then the C is the total amount of money that he collects on a randomly selected trip. Okay, so in interpretation, I would say, or, oh my gosh, why is this showing up over here? There we go. Sorry. I'll make my font a little smaller here. I'll type it out. For any randomly selected trip, Pete is expected to collect $562.50. Okay, so you can either say that, as long as you use the word expected, you're good, or you could say, another way to write it is, why does that always default to a really big font? I don't know. On average, Pete can expect to collect $562.50 per Jeep tour. Okay, So basically, as long as you have the word on average or expected, you're good to go. All right. And we did make this histogram yesterday by hand. If you remember, we did a quick sketch of it yesterday. So as you can see, they put the mean, which I know we just calculated. Well, look at this. It's actually right here on the bottom. And they're labeling it mu of x or mu of c in this case. And they have it kind of like a balance point because the mean's like a balance point. So picture a piece of wood and the wood being like on a cantilever. And basically, if you put the mean in the middle, it would balance this way, okay? So there's your mean. So now I want to show you guys how you can check it in the calculator. All right, so to check it in the calculator, we're going to enter the data in L1 and L2. Enter data in L1 is going to be the x values, and L2 is going to be the p of x values. And then after you do that, you're going to do stat calc 1 bar stat. Okay, pretty straightforward. You've done it before. Press stat, go over to the right to calc, and choose number 1 bar stats. But the difference is you have to make sure that the x list is going to be the L1, which is the x values. But then the y list is going to be the L2, which is the frequencies, the frequency list. Because you have to consider the fact that the probabilities are going to be in L2, okay? So I'm going to do that in a minute. Let's just see if I can select this and make it a little smaller. There we go. Perfect. So let's do it when you get a chance. Pause the video, and then we're going to go back to the data. We're going to do stat edit, and then we're going to do, so this was stat edit, stat 1 edit L102, okay? All right, so let's go back. So L1 is going to be your x values, and L2 is going to be the probabilities, and then we're going to run the 1 bar stat. Okay, so we're going to put in 300, 450, 600, etc. Okay, so let's clear our list. We didn't. Second, plus sign, 4, clear your list, enter, stat, edit. And L1, you're going to put in 300, 450, 600, 750, and 900. Those are your x values. Those are what Pete is collecting per customer. And then the p of x's, we're going to put in L2. So it's going to be 0.15, 0.25, 0.35, 0.20, and 0.05. Okay, so now we're going to press stat calc 1 bar stat. We already know the answer, okay, because we did it by hand. Stat calc 1 bar stat. But now where it says frequency list, you have to press L2, which is second 2, because otherwise the calculator will ignore L2 and it's just going to do L1. So hit calculate, and boom, do you see the first thing on the top is x bar 562.5. It doesn't actually label it mu here, it labels it x bar. All right, so there you have it. So basically now if you look ahead, there's going to be some more questions related to the mean. You can do this one for practice, but you see this one is quite longer. So you don't actually have to write out all the steps for the notation, because that would be kind of ugly. So you're going to write mu of x or e of x equals, and you're going to just maybe do 1 or 2. You could even do the first term, showing that you know it's being multiplied. And then you could do a plus sign and then do a little dot, dot, dot. And then the last term, which is 10, and then 0.053. And then you're basically showing that you know that addition is happening here in between the scenes. And you're multiplying each term, multiply, 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 add. Again, you could do this by actually sitting there and multiplying them all, 0 times 0.001 plus 1 times 0.006, blah, 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 and add them all up. Or you could do stat edit, but you still, on the count, you have to do the notation, okay? So here's the notation to get full credit on the AP. And now I want you to actually do it, find me the answer, and then I want you to interpret it. Okay? Thank you for listening.